Hi, in today's video I would like to introduce a very nice problem of Japanese Mathematical Olympiad edition 1992, question number 3. Okay, here is the setup. We are going to prove this statement for all positive integer n superior or equal to 2. We have the sum as k goes from 1 to n minus 1 of n is divided by n minus k is multiplied by the reciprocal of 2k minus 1. The whole thing is strictly inferior than 4. Okay, in fact I have brought you this problem. It's very beautiful problem and also it's very tricky. Okay, so you might say I'm going to use the induction hypothesis in order to prove this inequality, but it's not. The induction hypothesis doesn't work here. Okay, since the induction hypothesis is not going to work here, we are going to use the absurd proof. We are going to use AMGM, arithmetic mean value theorem. It's very important and useful theorem, especially for the students who are preparing for the International Mathematical Olympiad. It's very important theorem. Okay, I'm going to give you a general form of this theorem. We have this theorem is called AMGM, arithmetic mean geometry mean value theorem. We have x1 through the xn is divided by n terms is superior or equal to nth root of this product x1 is multiplied by x2 and all the way down to the xn. Go ahead, pause this video if you would like to give that try to this problem. When you worry, come back to see the full solution. Okay, let's go through the solution. So in order to prove this one, we are going to assume this sum is superior or equal to 4. Okay, at the end of term we will find the contradiction. Okay, let's go ahead to do it. So I'm going to assume this correct. At the end of term I will find the contradiction. Okay, so now I'm going to distribute this one. So the sum of n is divided by n minus k, as k goes from 1 to n minus 1 is multiplied by 1 over 2k minus 1 equal to, I'm going to distribute this one. I will get n over n minus 1 is multiplied by 1 over, I'm going to replace k with 1. I will get 2 minus 1, which is 1. For the second term I will get n over n minus 2 is multiplied by 1 over 3 and all the way down to the plus and all the way down to the n over n. I'm going to replace k with n minus 1, which is n minus 1. I'm going to replace k with n minus 1. I will get n minus n plus 1, which is 1. Okay, I will get 1 here is multiplied by 1 over, I'm going to replace k with n minus 1. I get 2n minus 1 minus 1, which is 2n minus 3. Okay, now I'm going to apply AMGM. Okay, so let's call this sum as a capital A. So this is the capital A is superior or equal to, we have n minus 1 term because we have k start from 1 and ends with n minus 1. So I will have n minus 1 terms here. So n minus 1, the capital is superior or equal to n minus 1 is multiplied by the product of n is divided by n minus 1 is multiplied by 1 is multiplied by n over n minus 2 is multiplied by 1 over 3 is multiplied and all the way down is multiplied by n over 1 is multiplied by 1 over 2n minus 3. Okay, so n minus 1 is multiplied by this product. I'm going to raise 1 over n minus 1 as an exponent. I will get 1 over n minus 1 here. Okay, I'm going to select and separate n terms. So I will get capital A is superior or equal to n minus 1. This one is multiplied by n over n minus 1 is multiplied by n over n minus 2 and all the way down to n over 1. So the whole thing is multiplied by the second product, which is 1, is multiplied by 1 over 3, is multiplied by 1 over 5, and all the way down to the 1 over 2n minus 3. Okay, so the whole thing is raised to the 1 over n minus 1. Okay, now So now this one, since n is multiplied by n and all the way down to the n, so this one is a n minus 1 times. Okay, I will get n minus 1 is multiplied by n to the n minus 1 is divided by this product, which is n minus 1 is multiplied by n minus 2 and all the way down to the 1, and is multiplied by the second product, which is 1, 3, and all the way down to n minus 3. So the whole thing is raised to 1 over n minus 1. Okay, so this n minus 1 will be cancelled out with this exponent. Okay, so I will get here, I will get n. So now I will get the capital A is superior or equal to n minus 1. I'm going to take this n outside because it's free from exponent. So I will get n minus 1 is multiplied by n is multiplied by the reciprocal of 1 over n minus 1 is multiplied by n minus 2 is multiplied by n minus 3 and all the way down to the 1. This one is multiplied by the second product, which is 1 is multiplied by 3 and all the way down to the 2n minus 3. Okay, so this second term is odd numbers, this one is a factorial. Okay, so this one is raised to the 1 over n minus 1. So I'm going to clean up the board and bring this one at the top and continue with our problem. In the last board, we were arguing for this inequality and came up with this result. So we found the sum of this inequality is superior or equal to this product. So n minus 1 is multiplied by n and is multiplied by this, the reciprocal of this product, which is raised to the exponent of 1 over n minus 1. So now I'm going to bring this one down here. Let's call it as a capital A. Is superior or equal to this one. I'm going to apply the exponential rule here. I will get n is multiplied, n minus 1 is multiplied by n e to the 1 over n minus 1 natural log of this product of n minus 1 is multiplied by n minus 2 is multiplied by n minus 3 and all the way down to 1. In the same time, this product is multiplied by the second product, which is 1 over 3 is multiplied by 5 and all the way down to the n minus 3. Okay, so this one, capital A, is superior or equal to n minus 1 is multiplied by n. I'm going to put the reciprocal of this one is given as e to the minus 1 over n minus 1 natural log of n minus 1 is multiplied by n minus 2 is multiplied by n minus 3 and all the way down to the 1. I'm going to separate this natural log by two parts. I'm doing plus natural log of 1 is multiplied by 3 is multiplied by 5 and all the way down to the n minus 3. Okay, so the capital A is superior or equal to n minus 1 is multiplied by n is multiplied by e to the minus 1 over n minus 1 of natural log. I'm going to put this one as a product. So the product of to the n minus k, as k goes from 1 to the n minus 1, okay, plus natural log of the product to k minus 1, as k goes from 1 to n minus 1 of 2k minus 1. I'm going to take this product outside of this natural log. I will get a sum. Since both terms are having the same error, as k goes from 1 to n minus 1 for both of them, so I'm going to put the sum notation as a common factor for two terms. I will get e to the minus 1 over n minus 1 is multiplied by the sum of, as k goes from 1 to n minus 1, is multiplied by natural log of n minus k plus natural log of 2k minus 1. Okay, I'm going to bring this one at the top and continue with our problem. So in the last board I was working on this inequality and came up with this result. I'm going to simplify this one. I'm going to take this both natural log into one natural log. Okay, I will get, so this sum as n over n minus k, as k goes from 1 to n minus 1, is multiplied by 1 over 2k minus 1, is superior or equal to this one, as n is multiplied by n minus 1, is multiplied by this e to the minus the sum of natural log of n minus k is multiplied by 2k minus 1. Okay, as k goes from 1 to the n minus 1, all over n minus 1. Okay, so I just applied the natural log rule here. If you take a look at this product is superior or equal to 1 always, because if you replace k with 1, we know n is superior or equal to 2. Let's consider n equal to 2, for example. 2 minus 1 is giving us 1. 2 minus 1, which is 1. 1 is multiplied by 1 is giving us 1. Natural log of 1 equal to 0. Okay, that means this product is always superior or equal to 1. Since this product is superior or equal to 1, that means natural log of this one is always superior than 0. That means natural log of n minus k is multiplied by 2k minus 1 is superior or equal to 0. Okay, moreover, we have n is superior or equal to 2. That means n minus 1 is superior or equal to 1. This one equivalent, n is multiplied by n minus 1 is superior or equal to n. Okay, and n is superior or equal to 2. Okay, so this one implies this sum, let's call it as a capital A. The capital A is superior or equal to 2 times is multiplied by this one, which is e to the minus of natural log of n minus k is multiplied by 2k minus 1 is divided by n minus 1, as k goes from 1 to n minus 1. Since this natural log of this product is superior or equal to 0, okay, that means this whole number, including the e to the minus of this one, is inferior or equal to 1. Okay, by multiplying 2 by this one, I will get 2 is multiplied by this one. Let's call it as a capital B, is multiplied B, is inferior or equal to 2. Okay, and in the same time we found A is superior or equal to this term to B, and at the same time this term is inferior or equal to 2, because we assume this sum as a capital A is superior or equal to 4, and we found a contradiction. Okay, that means our assumption was wrong. This sum is not superior or equal to 4. This sum must be strictly inferior than 4. Okay, now I have done with this problem. If you are interested in watching this problem, just don't forget to support us with your like and subscribe. Thank you for watching. I will see you in next video. Bye.